All right, lesson 23. Using quadratic expressions in vertex form, so similar to what we did yesterday. Gives us two graphs here, f of x and g of x. F of x is a blue, g of x is a black. It says f of 1 can be expressed in words. Find the value when x is 1. Can find or compute. So when x is 1, this is the blue one because it's f. What is the y value when x is 1? 1. 10 is on the graph right there. 10 is correct. How about when f is 3? Looks to be correct. F is 10. Can't tell on the graph, right? 10 is going to be up here somewhere. So I got to plug it in. 10 minus 4 squared plus 1.
It's 36 plus 4 is 37.
37. Again, you can't see that on a graph because it'd be way up here. Can you find an x value that would make f of x less than 1?
No.
Why not?
Because your y intercept is not 1 or
Yeah, this is our minimum point. It never gets any lower than 1. So where does it get less than 1? It doesn't. It never goes below 1. Somebody other than Caleb. Can you find a value that would make it over 10,000? Yeah, absolutely. This thing goes on forever, so it's eventually going to get to 10,000. Just for a couple examples, 110 would give you a number bigger, and negative 100 would also give you a number bigger than 10,000 if you were to plug that back in. Okay, switching focus to the black one, black graph. X is 9. What's the y value?
-2.
Somebody other than Caleb, please. 13. What? I think it's right on the line, isn't it? I'm going 6. G of 2. Again, you can't see 2 on the graph. Eventually it'll get there. So we got to plug it back into the equation. 2 minus 12. 2 minus 12. Negative 10 squared. 100. Put a negative sign in front of it. Plus 7. Negative 100 plus 7. Negative 93. You have $100 and he's negative 100 plus 7. You're $100 in the hole and you paid me back 7. What do you owe me? Not 107. You owe me $93. When does our value get bigger than 7? When does a black graph get above 7? Doesn't. That's the top of the graph. That is the maximum. Less than 10,000, again, it will get there eventually. It goes on forever going down. 200 and negative 200, in fact, if you would plug it in, would give you less than 10,000. Graphs of min and max. Okay, they go through some explanations here. The main point I want you to look at from this first example, there are two things parabolas can do. It's going to open up or down. If it opens down, do you have a min or a max? You have a max. So you have a point where it will be the tallest on your graph ever. When it opens up, you now have the lowest point of the graph. It will be the bottom of your graph. So I think that's easier to look at. And then I think we can answer the next chart just by knowing, does it open up or down? First one. Are we going to have a min or a max?
Max.
Why?
Because of negative.
Because it opens down. Next one. Minimum, because it's a positive out front. Minimum. Minimum. Last one is max. So I think that makes it super easy. Does it open up or down? That's all you got to know.
Is there ever a way you can assign this parabola?
Good question. There is. But they both occur at the same time. And it's got a different name. It's called a hyperbola. And you could also have one that's slant as well. That's different. These are the only ones we're worrying about this year. The other ones are coming though.
Next year?
You might see those next year. All right, we're going to skip this guy, go right to the last question there. Directions. Ken, would you read that, please?
Graph represents a function B that one of the revenue from the sale of tickets for performance B, a Shakespearean comedy. Both functions B represents the price of coins to be given, both revenues and prices are measured in dollars. Without creating the graph A, determine which performance gives the greater maximum revenue. Tickets are $80 each. Explain or show your reasoning.
All right, it says without creating a graph, which one, right? It says it doesn't want us to graph the first one. We can answer some questions though. What ticket price would give us the most money for B? $3 would produce how much revenue? 900, that is a max, right? This other one, and you can tell once it is 0 and $6 is when I will make zero money. Let's figure out when I'd make zero money for this equation. This is a separate one. This is performance A, function A. Well, it's pretty easy for this one. What would make that zero?
6 or 0 or 0.
Zero. If you charge $0, you're not going to make any money. What makes this one 0?
6.
I don't know, set it equal to 0. Subtract 600. Divide by negative 75. What's 600 divided by 75? 6? 8? Anybody confirm 6 or 8? 8? All right, so there's the other one where I'll make $0 if I charge $8. So what's in the middle of 0 and 8? 4. So that means my max, it will open downward because it's going to be a negative p squared. My max is going to be 4 something. I don't know how much money I'm going to make. It doesn't want me to graph it. So let's plug it in. 4 times 600 minus 75 times 4. Four times 600 minus 75 times 4 is 300. 4 4 times 300, $1,200. All right, so now that we have them compared, go back to the question. Which performance will give us the maximum revenue? Function A or B? Yeah, $1,200 is more than 900. Would have been nice if they gave us two graphs. They did not. One's a graph, one's one an equation. That's perfectly fine. All right, let's take a peek at the homework, see if there's anything that stands out to be issues there. Let's look at 3. 1 and 2 I think are pretty easy. 3 wants you to find the vertex. They're all in vertex form, so that should be easy. And then say if it's a min or max. Four we can handle. 5 is matching. 6, multiple choice. Which one is irrational answers? True or false on 7. Make sure you say Y. Don't just write T or F there. Eight is good. 9 is a review. I'm curious how you'll do with 9. Little review from Unit 5. So 1 through 9 for today. Lots of time to work.